Now here the question is, A is a set containing n elements. A subset P is selected at random from set A, and set A is then reconstructed by replacing the elements. A subset Q is also chosen, may be void also. The probability that number of elements in P is equal to number of elements in Q. Now, total number of ways of choosing P and Q will be, now for P we have two choices for each element, so there will be 2 into 2 into 2 n times, and for Q also it will be 2 into 2 into 2 n times. So total number of ways of choosing P and Q will be 4 to the power n. Now this first case is number of elements in P is equal to number of elements in Q. Either both of them, they'll have 0 elements or 1 element or 2 elements up to n elements. Now if they have both 0, then it will be nc0 square, both 1, nc1 square up to nc(n) square, and from binomial we know that this is nothing but this is 2n(cn). So this required probability will be 2n(cn) divided by 4 to the power n, which is this option P. So this A, it matches with P. Now the second one is number of elements in P is more than that in Q. Now we'll have three cases. Either P will have more elements than Q, or they'll have same number of elements, or number of elements in P is less than number of elements in Q. Now there is no difference between the two sets and their conditions. That means number of elements in this case will be same as number of elements in the other case. So if we have to find this probability will be simply 1 by 2 and then 1 minus when they have equal number of elements, which is 2n(cn) upon 4 to the power n. Now we can write this as 4 to the power n minus 2n(cn) upon 2 to the power 2n plus 1, which is your option Q. So this B, it matches with Q. Now this third one is P intersection Q is 5. Now if P intersection Q is 5, then for each element we have three choices. Either it'll go to P, or it'll go to Q, or it won't go to any of P. So total number of ways of choosing two subsets P and Q such that their intersection is 5 will be 3 to the power n, and this probability will be 3 to the power n divided by 4 to the power n, which is your option S. So this C, it matches with S. Now D is Q is a subset of P. Now if Q is a subset of P, then first case is when Q doesn't have any element. So it is nc0. Then in that case, for each element, we have two choices. So we can construct this P in 2 to the power n ways. Now if there is one element in Q, now that element is already present in P, then for the remaining n-1 elements, we'll have 2 to the power n-1 choices. And then it will be nc2, 2 to the power of n-2, and then it will be ncn, 2 to the power 0, which is nothing but, which is binomial expansion of 3 to the power n. So favorable cases where Q is a subset of P is 3 to the power n. That means this required probability will be 3 to the power n upon 4 to the power n. So this D, it also matches with S. So A matches with P, B with Q, C with S, and D with S. And that is the answer to this question.